already been because it's so good morning. One, two, three. Good morning. So this is the second half of the core working group meeting. We had a pretty productive meeting yesterday and already covered some of the items that were on the agenda for today. Just to remind people, this is an IETF meeting. The IPR principles of the IETF apply, including the Note well. And this is the original agenda for today. And we are going to move up the DevURN item because Yari is only available around 10 o'clock. And we already covered 2 items and we have covered this one, but we have to return to it. So we will do that. Any other things we need to change in the agenda? Okay, in that case, we'll jump into Cocoa. Carlos.
Okay, good morning, everyone. My name is Carlos Gomez, and I'm going to present the current status and the last update of the draft entitled COAP Simple Congestion Control Advanced, also known as COCO. So first of all, let's take a look at the status of the draft. The document is currently in working group state, submitted to ISG for publication, and the last revision is -03, which incorporates mostly editorial updates and addresses comments by Wesley Eddy as the TSVR early review, and Mirja Kulowin, who's the responsible AD for this document. And by the way, both reviewers have expressed that the last revision of the document satisfies their comments. And then for the next revision, we need to address the comments by 4 additional reviewers. That is the reviews from Scott Bradner, Vincent Roca, and Christer Holmberg. And in addition, there was an additional set of comments received yesterday by Gori. So we need to address all these additional comments. Later today in the presentation, I'll refer to how we plan or which is our position related with the comment by Scott Bradner. However, the other 3 reviews have been received just a few days ago or even a few hours ago. So for those, we don't have slides. We're still processing the comments. Okay, so let's go quickly through the updates in -03. The first update is in section 1, introduction. So now we have added a new paragraph there, which in its original form was previously in section 5, which is the section that focuses on nouns. And now it has been adapted, made a bit more general, and it provides an overview on what COCO does. We explained that COCO computes the RTO based on weak or strong RTTs. Because we use weak RTTs in addition to strong RTTs, the reaction of COCO to congestion is by using a low ascending rate, and specifically for nouns, the ascending rate is limited to 1 message per RTO, per destination endpoint, which is more conservative if everything works as expected than what is stated in RFC 7641, which would define a limit of 1 message per RTT per destination endpoint. Then in section 3, we have added details on the scenarios where COCO has been found to perform well. We explained that these scenarios comprise latencies that range from milliseconds to up to peaks of dozens of seconds. There's an additional comment by Jaime, which is that we might need to detail a bit more which reference contributes to what within this range. Also, scenarios used in evaluations comprise single hop and multi-hop network topologies and link technologies that have been used in evaluations comprise 15.4, GPRS, UMTS, and Wi-Fi. Also, we've added that COCO is expected to work suitably across the general internet, so not only within the limits of a constrained node network. Then in section 4.2, which is the one that defines the algorithm for the RTO, we have added an explanation for the default weight values used for the strong and weak RTO estimators. Basically, we have found that these work well in evaluations that are referenced in Appendix A of the document. And also in 4.2.1, we've added an explicit note on the fact that the variable backoff factor used in COCO replaces the simple exponential backoff that has been traditionally used in TCP and also in default CoAP. Then in section 4.3, we explain that the state of RTO estimators for an endpoint should be kept long enough. And now we provide the motivation for this. The idea is we want to avoid frequent returns to inappropriate initial values of the algorithm. And also we write that for default parameters in CoAP, it is recommended to keep such state for at least 255 seconds. So, well, this was a must, not a recommendation in 0.2. So this is possibly the only technical update in 0.3. And also now we make explicit the relationship between this time, at least 255 seconds, and the parameters of CoAP that are in use, especially in particular, those that are relevant are those in section 4.8 of RFC 7252. And it is, anyway, this time, the time during which we need to keep the state for the RTO estimator needs to scale with those parameters. And also we have made a number of minor editorial updates throughout the document. So for the next revision, we have several comments as mentioned before. So on Scott Brandner's comment, he has only one comment, which is that the draft makes no reference to RFC 5033, which is a document that provides guidelines for specifying new congestion control algorithms for the internet. However, we can argue that we have actually taken into account such guidance when designing COCO. And this slide and the next one show which are the different guidelines in 5033 and which is our position on that.
Carlos, before you go into the details on that, maybe we can use of the adult supervision that the transport area has provided for us today. Gary Fairhurst is here, and maybe you can make a quick comment on the microphone on how you think 5033 should influence what we are doing. Sorry for surprising you with this. Might have to switch it on. The other microphone was not switched on either.
Hi, I'm Gary Fairhurst. Aha, that's good, amplified. Okay, so I'm coming at this just parachuting into the room. So my initial response was just to provide some comments as I read through it. On the 5033, I think this guidance is mainly meant for transport protocols like the ones that are listed, TCP, SCTP, DCCP, presumably QUIC, and other transport protocols. The transport I see here looks a bit more like what's described in RFC 8085. In other words, it's a timer-based lockstep retransmission method. So maybe some of these checklists do not apply, and you could say this. But point number one does apply. You still shouldn't impact standard transports. So if there's anything that happens here that could appear on the internet and could stop TCP behaving in the way it normally does, then I think you have to consider that. So I think you probably need some sentence that addresses this, but I'm not sure all of 5033 applies.
Thank you.
Shall I maybe just proceed with the list?
Just quickly go through them, I think.
So, well, in 5033, there are 9 guidelines, and you can see for each one of them, we have the lowest level bullet, which indicates our position on how COCO or the design of COCO has taken them into consideration. So the first is about deviations from congestion control principles in 2914 need to be motivated. However, we believe we have our COCO design is aligned with those congestion control principles. Then for guideline 1, we believe COCO has no negative impact on existing protocols such as TCP, although we may want to discuss something later with a second presentation in this lot. Then COCO has been designed for difficult environments in terms of what 5033 defines for this term. Then also a range of environments have been evaluated, as has been shown before. Also, we believe COCO protects against congestion collapse because of the values used for the variable backup factor when retries are needed. We have evaluated fairness of the new congestion control mechanism, and we have found it is high, especially thanks to how the variable backup factor compensates some possible potential issues in terms of fairness in some topologies. Then we have considered a situation where there might be performance issues with misbehaving nodes. We have text on that in the security consideration section. And in that case, when nodes may want to drop packets to decrease performance, we explain that the weak estimator may help recovering from such situation. Also, we've evaluated situations like in guideline 7, where there is some sudden event, for example, a number of sensors that many of them detect some event at the same time and want to communicate such detection, leading to temporary congestion. And we found that COCO helps restoring normal network state quickly. And the last guideline is about incremental deployment, and we believe that COCO runs correctly in current constrained node network scenarios and also in scenarios where a constrained node communicates with a not so constrained device, possibly as cloud infrastructure, for example. Okay, so that's all from my side. Any additional comments or questions?
Okay, so if there are no further comments on this, we have some new results that Marco Coelho is going to present. So please go ahead.
Okay, do you hear me? Good. This is joint work with my team, Ilpo, Ivo, and Laura, together with Carl Chen. So the system under study that we are using is, we use a varying number of IoT devices to increase the load, so the congestion in the first place. And we run over a constraint bottleneck link, so downlink 30 kilobits per second, uplink 60 kilobits per second round trip time, a little bit over 600 milliseconds. So this kind of emulates an NB-IoT-like environment, but we don't say that it is NB-IoT environment. So good enough to see the effects. And from the router to the fixed host, we have a random delay between 10 and 20 milliseconds. And this is the fast link, so it's not kind of affecting the affecting the traffic in any other way. On the router, we have varying buffer size, use varying buffer sizes to recommended PDB size 2,500 bytes, kind of a small buffer, and then increasing sizes for the buffers. And then we have the, as we call it, infinite buffer. So it's not, of course, infinite, but it's large enough so that there will be no packet losses with the load that we give. We implemented the client and server using libcope. So, or actually for the default cope, so the 7252 implementation, we used the, as it was implemented in there, we added some bug fixes, but that's all. COCO was implemented with the draft version 01 as well as the 03, because we noticed that there was a change in the variable backup factor from 101 to 02. So we wanted to experiment with that as well. For the default COP and COCOA, we modified the max retransmit to 20. This is just to see that there are no aborts for any of the exchanges. So the max retransmit of 4 is defined. This is just to make sure that our tests run all the way to the end and we get the results that are kind of comparable. 32 seconds for COCOA was specified as specified was used for the max RTO. For the default COP, we use 60 seconds, so because otherwise, in some cases, the RTO fires very high, and it's kind of those tests would take a very long time. We implemented COP or TCP as per draft 09, and it includes only the necessary features kind of to run the tests. And we use the Linux TCP, but we modified that so that we don't use any of the fancy features. So we use just new Reno, so we disable SAC, cubic timestamps, FRTO, all these experimental features, TCP rack, and so on. Modified the delay act time to be constant 200 milliseconds. And then we also, for the retry counts for TCP, we modified them to high enough so that none of the TCP connections won't abort. Okay, for the workload, we use small request response exchanges so that they fit into a single COP message. And then we increase the load by using one client all the way up to 400 clients. So this gives the kind of a increasing trend in the offered load, and at the same time, of course, the congestion. So we put the system in a real stress with this higher number of clients or client-server pairs. And we use two types of workloads, continuous clients, where those clients, they exchange 50 request response exchanges. And for TCP, the TCP connection is pre-established, so the three-way handshake doesn't affect the measurement, so we can compare the TCP with the other two, so the default COP and COCOA. Then we have the random clients, which emulate short-lived clients. So each short-lived random client exchanges random number from 1 to 10 message exchanges, and then another client starts immediately and exchanges yet another 1 to 10 until 50 exchanges are completed. So this is kind of we can compare the results with the random and the continuous client in this sense. The difference, of course, being there that now the system is putting, or those clients are putting more test because the retransmission times are reinitialized for each random client, and the same for the TCP. The TCP connection or the new TCP connection is open for each new random client. Okay, to the test results. So here we have the results for 1 and 10 clients. So this just provide a baseline, so the flow completion time, so how long it does take to complete these 50 exchanges. It takes something like roughly 33 seconds in all cases, except with the COP or TCP, with the random clients, where, of course, because TCP needs to kind of establish a new connection every now and then, that gives the overhead there. So those TCP completion times are over 40 seconds. And then if you look at the 50 clients case, now the full completion times increase to about 60 seconds. And this is mostly because of the queuing delay. So here we have more load, but still not quite congesting the link, with the exception that the TCP, which has a larger header, it means that the less TCP packets fit into the router buffer, so the TCP has a little bit more losses compared to the default COP and COCOA, which has just a few losses in there. That shows in the left-hand side, with the continuous clients, the TCP has a little bit higher flow completion time. And then, of course, on the right-hand side, because of the new TCP connections are created, there is this clear difference there, of course. Okay, then 100 clients, and now something starts to happen. If you look at what now happens is that when we increase the close, now the system becomes congested, and with the infinite buffer, or when we increase the size of the buffer, of course, more queuing delay occurs. And now, because of the queuing delay, the RTT is increased over 2.5 seconds. This means that now, when we are using the initial RTO with default CoAP and COCOA from 2 to 3 seconds, now this initial retransmission timeout starts to happen. And COCOA and TCP, they handle this just fine because they adjust the timer. So in the early stages, they need to retransmit a few times, but then they adjust the timer and everything is fine. But with the default CoAP, each time when it retransmits, it backs off, which is fine. So that's what it needs to do. But then for the next exchange, it restores the initial timeout and does it again, retransmits and again and again. And if you look at the number of retransmissions, we will see that for 50 exchanges, it needs basically retransmit every request once. So it does double the work. And now this is the first sign of the consistent collapse. So there is no kind of a fine line when we have a consistent collapse. The consistent collapse is basically defined that if we increase the load and the useful work of the system then decreases, then we have signs of the consistent collapse. And that's what we will see with the default code when we further increase the load. So with the 200 clients, if you look at the infinite buffers, what happens there, that happens with the default code, it gets slower and slower. But if you look at the small buffer on the left-hand side, both with the continuous clients, there we can see that with the flow completion times, there is some difference between TCP and default code and COCOA. So basically they are pretty much the same, but there is much more variation with TCP. And this is because TCP does the full TCP compatible backoff. It means that some of the clients, they wait for longer, they back off for longer time, while the others can proceed. But this is different from what happens with the default CoAP, because they both, COCOA and default CoAP, they have the same problem, that they restore for the next exchange the retransmission time. If you look at the number of retransmissions, there is a clear difference with TCP. So the small buffer, 2,500 bytes with the circled the TCP, and then the default CoAP and COCOA. This means that now this is not visible in the flow completion time, because all these unnecessary retransmissions, too aggressive retransmissions that default CoAP and COCOA do, they are dropped in the router. So then they kind of are so-called undelivered retransmissions, which is a second type of a sign of the consistent collapse, because these undelivered retransmissions, they affect the network before the bottleneck. And if we have too much of those, then we may have a consistent collapse somewhere else. Okay, and now if we increase then the load to the 400 clients, that is the size that we were offering, we will see that the default CoAP, of course, still has the problem. But interestingly, what happens now is that the COCOA also starts to collapse with the continuous clients, not as badly as the default CoAP, and with the random clients on the right-hand side, COCOA collapses as well. And what is more interesting is that the version 03 is worse than the 01. And why this happens? If you look at the number of retransmissions, this shows up there. If you look at the left-hand side, first the continuous clients with the infinite buffer, there we have a see that those Cocoa version 3 has much more retransmissions than the version 1, and but not that much as the default COAP has. And what happens there is that a bit more than half of the clients, they are not able to adjust their timer, because now the round trip time is so high that during the first round trips, they are not even able to get the weak sample. And why they don't get weak sample with the O3, but they get with the O1 is the difference that the variable backoff factor was changed. The original definition was that we look at the RTO estimate and compare whether it is about 3 seconds, then we use the backoff factor 0.5, and if it's below 3 seconds, we use the binary exponential. And now what happens there for those clients that get the sample and are able to adjust their timers, they practically use, for the first retransmission, they double the timer, but for the next one, they don't anymore. While in the O1, they continue with the initial timer using the doubling, so which is more conservative. This is one difference. And then there's another difference, and this relates to the aging. So aging is defined that if there is no update to the timer for 4 times the current RTO value, then we age. And it is defined that if the RTO value is over 3 seconds, as here it is, then we take the timer, the retransmission timeout value down towards the initial values, which is exactly the wrong thing here, because now our delay is increasing. We should be kind of increasing the value, not decreasing the value. And then the third thing that affects is that the Cocoa is that it has the upper bound of 32 seconds for the timer. And in this case, actually, especially when we are backing off, our timer should go beyond, even beyond 32 seconds. All right, so these are our results, and it seems to me that the protocol actions are needed. So with the 7252, because we don't employ full backoff that is TCP compatible, so it means that we are restoring the 2 seconds initial RTO for the next exchange. This is the basic problem with the default COAP. So the Cocoa has the same problem, with the difference, of course, that it is not restoring the initial RTO value, but the current RTO estimate. And the current RTO estimate, in some cases, not enough, as we saw. And with the RTO estimate larger than 3, we are kind of applying this aging blindly. We decrease the RTO, as we saw in some cases. This is not a good thing. It is kind of justified there in the Cocoa draft that after idle periods is a good thing. It might be a good thing, but not always. So this calls for an update as well. And then also this upper bound of 32 seconds for RTO. This is actually in conflict with the draft IETF TCPM RTO considerations. So these are general considerations for the timer mechanism that we should use in the internet. So the action points, I think what we need is to edit the Cocoa draft. That should be easy, because we can address it. But then for the 7252, we seems that we are needing an update. So we could write a short ID that updates. That should be easy thing to do. It's just a couple of pages maybe. And for the Cocoa, then we should reconsider this aging at the RTO values larger than 3, and as well as we should reconsider this upper bound of 32 seconds, which actually now after the change in the version 03, it doesn't apply in any other case anymore, except when the RTO value is above 7 seconds, roughly about 7 seconds. We never reached the 32 with the max retransmit of 4. Okay, Thank you. So
Can you go back to the slide with the meat on it?
which one?
Previous slide?
Please. Okay.
So just pro tip, never put a thank you Q&A slide at the end of your presentation, because that's not what we are discussing. Okay, so I would like to make several points here. One about default CoAP, which I think we should lay to rest quickly. Of course, we know that there is no state kept there in CoAP. But if you think this change needs to be made, you will have to make it for TCP too, because TCP has exactly the same problem that when you
TCP, you said?
TCP.
No, DCP backs off, and then it doesn't restore the RTO value, but it keeps the exponentially backed off value until you get an acknowledgement without retransmissions. So when you send a new segment and get an acknowledgement for that without retransmission, only after that, this is 6298.
If I open,
It's not same.
If I open a new TCP connection, I get new state.
Right.
And that's exactly what happens with CoAP here. So we all have experienced the congestion collapse that you get when the network is not even fast enough to open the TCP connection. Because TCP has exactly the same property here.
No, you don't, because we see here, this for the random clients, TCP is open and new TCP comes every now and then. What happens that you retransmit your SYN, you have a timer, right?
Yes.
And then if the delay is too much, then you retransmit with the backup factor. And
Yes.
after a while, you get the SYNAC, right? And then for the next segment, you keep this higher and you won't retransmit anymore.
You never get there when you experience the congestion collapse I just described.
You will get it if you retransmit long enough, meaning that your retries are not too low. And today what the TCP uses as a default is high enough for, I would say, almost all foreseen kind of environments.
So you're comparing the case where TCP keeps state for the connection. And CoAP, of course, does not keep state
It
because
keeps-
these are independent
You mean the
exchanges.
default CoAP is not keeping any state?
Right. So,
But that's the problem.
No, yeah, yes, and Cocoa is the fix for that.
Yeah. Okay. Then if we are not keeping any state, then the initial RTO of 2 seconds is way too low.
For your specific experiment setup, yes.
No, in general, that's also there in the UDP guidelines. It says at least 3 seconds.
Okay.
Yeah.
Okay, so yeah, between 2.5 and 3 seconds,
Yeah, but okay,
that's the difference.
I understand that with some of the constraint devices, you are not able to keep the state. But that's not the whole story. What we should say there in the spec is that if it's possible, you should keep the state. And for most devices, or at least a large number of devices, this should be okay today.
So the recommendation that we should be making is the recommendation that we should be making is if you can keep the state, do COCO.
Okay, fine. Yeah.
I think
in a COCO you should do the same as the TCP does, and currently it does not do that.
Right. I just wanted to lay to rest the suggestion that we have to change 7 to 52 because I don't think we have to. And
I think what we need to do, we need to reconsider at least what is the initial RTO value, which is given now as 2 seconds. That should be reconsidered.
Well, it's between 2 and 3 seconds.
It's between 2 and 3, but still below 3.
Yes.
On the average, 2.5.
Yes.
Yeah.
I'm not sure that is going to break the internet. With respect to COCO, I think there are a number of really useful observations here. One thing is the 32 seconds that is the upper bound for the RTO in COCO really is based on the default parameters. So if you have a max retransmit of 5, this is exactly what you should use as your upper bound. While if you have a much larger max retransmit, then you also should change your upper bound. And that's something that we definitely missed when defining COCO. So this should be a tunable that depends on max retransmit. So that's one important observation here. The
Yeah,
other one,
but even with the current parameters, if you have 4 retransmissions, it goes above 32 seconds. If your RTO estimate value is more than 7 seconds, and in the 01 version, it happens also with 2 seconds initial RTO value.
yes.
Yeah.
Okay, so maybe the function that we need to define for that is based on max retransmit won't yield exactly 32 even for the current default value of max retransmit. So let's discuss that. I think that's one point we can take home. The other one is the aging. The point is that the number 32 should depend on max retransmit, and that maybe the number 32 also isn't right for the default value of max retransmit.
So sorry, could you? I didn't follow what you mean. Could you repeat?
Yes. So the observation is that the number 32 as the upper bound for the RTO should depend on max retransmit, and that also maybe the value 32 for the default value of max retransmit is not sufficient. Okay, so the other thing is the aging issue, and I think that's really interesting because your simulation is based on a situation where you essentially have continuous conditions for the whole time of the simulation. Now, aging was not designed to handle continuous conditions, but it was designed to handle bursts. So if we have a burst in the network, we want to go back to a relatively normal situation quickly. And the problem with not having aging is that random losses make your reaction can make your reaction time very high when you don't have some form of aging. So I think fundamentally the idea of aging is right. And from a deployment perspective, nobody in their right mind would deploy COCO if we didn't have aging. Because some random losses for a quick burst would turn your implementation into a very sluggish one. So we have to have some form of aging. Now
I understand the basis for that, but the message is that in some settings, like with the high delay, it provides the wrong result because if you have more than 2 retransmits, it is guaranteed that aging comes into the play and decreases the RTO value. And in some cases, if your dithering value is more closer to 3 seconds, what happens is that your timer ages before you get the weak sample. So with the second retransmit, that is also possible, and that happens in our tests as well. And this is not a good thing. That you first age the value and then you get the sample and you recalculate with this aged value.
Okay, so I think we have an interesting misunderstanding here. Aging is supposed to be used when you're idle.
Yes, that was our understanding with 01 version, and that's why we first didn't even implement aging, then we implemented. But with 03, it has 2 examples for the aging. The example, especially for the below 1 second case, exactly shows that during you are retransmitting, it kind of takes it up, and it doesn't mention anything that it should be used only when you are idle, when about 3 seconds. So it should be clarified, at least in this case.
Oh, so
we implemented exactly what the draft says.
So doing the aging algorithm while you are still retransmitting, that will lead to problems. I agree with that.
Yeah.
So we have to clarify that.
Yeah, but with the idle case also, I think 4 times RTO or the high values, that probably is too short period. Because if you think about that your current RTO value, whatever your network setup is your RTO value is about 3 seconds. Such likely about 3 seconds. It means that you will age it in 12 seconds or a bit more than 12 seconds, right? And now it might be that your exchanges are such that they happen every 15 seconds. And if you get congested, you have a persistent congestion just because of these features of the default co-op, it does not necessarily go away within 15 seconds. So it is not necessarily a good idea to age the value in such a case, even though I admit that in a wireless case where you have wireless lossy, this is the hard problem because we have had this same problem with TCP and there is no solution. And the best solution there is to try to get the samples as often as you can. And in that sense, kind of a weak sample is maybe a good idea, but the problem is there that you have to use these ambitious samples with retransmissions, which actually give you very high value. It's better than nothing, but it's still problematic here. But the problem is hard.
Yeah, I agree that this is hard. Yeah. And one thing that when we discussed this was aging maybe should be more tunable, but of course that just throws over the problem into the court of the poor guy who has to configure the thing, and we know how well that works.
Sorry if I say that the one thing that is important, so we have this performance problem with the wireless, for sure, yes. But the congestion is the thing that we need to deal first. We need to ensure that we are safe on that side, and then we can do whatever modifications with the to handle the wireless losses better. That is kind of the basic guideline that we should have there.
Right, but we also have to have a protocol that's actually deployable. We have too little information. That's the whole problem. And we are trying to run an estimator that does something reasonably useful. And we know we in a network that just doesn't give you replies, you don't get enough information to actually always react in a sensible way. So again, I think what we need to take home here is that first of all, it needs to be made very clear that aging is only used in idle periods. And I would be interested to see your numbers when you actually implement it that way. Do you think your O1 numbers are representative of that? Or
Sorry.
So if you implement aging the way that the authors intended, which is that aging only applies when you're idle.
So that is pretty much the results that where we implemented O1 without aging.
Okay.
So it still has this problem with the random clients and the high enough load. So it has this concept. But the major cause for that is not retaining the backed off RTO value. That is the main cause. That if we fix that, then I think this aging and this upper bound of 32 seconds, they have a role there, but we mostly fix everything if we do that. And then we need to reconsider whether some other modification and what actually is, what of those are needed. Because that is the major cause.
Right.
So what you saw there is this that just this, because of aging, like we now implemented it kind of takes these problems or these problems occur just little bit earlier. But finally, they occur just because of if we don't retain this fact of RTO. Well, this is the main reason for the problems.
Yeah, and I think we have to look exactly into why that is not happening in your situation, because the current RTO estimate contains back-off information, and maybe we have to look into this a little bit more in detail, but probably can't do this at the microphone right now. Yeah, but thank you. This was really useful work, and I think it clearly shows that there are limits of the default curb congestion control, and there are also limits where the parameter set that we have defined for COCO works well, and we probably want to update it based on that information.
One of the orders. So one thing that wasn't on the slides, but is interesting and related to this congestion collapse, that actually even for this 400 clients, the actual RTT is only something like 10 to 15 seconds, depending on whether you have continuous or random clients. So it's still clearly below this, even this 32 seconds, if the congestion control would work well enough so that it would prevent this collapse. But now as the congestion control causes the collapse to happen, the actual RTT rises much higher, so you have these unnecessary retransmissions which consume some of the capacity. But not only that, they also increase the RTT much beyond what it could be. So if you have just one request reply per client, which is not always possible with random clients because the state is occasionally lost. But for continuous client, you can always have this, that you have just one request reply there, and with that even with 400 clients, it's slightly more than 10 seconds the actual RTT. So if we can prevent the collapse, the RTT also will be much lower. So this max RTO is not so significant anymore. So this case is not sort of pushing the load beyond the 32 seconds, but because of the collapse, the RTT goes that high.
Yes, every request was retransmitted at least 4 times, which means that the useful work that the system was doing was less than 20% of the capacity.
Can you go back to the 400?
It's not working anymore. So
page?
It's not working anymore. I can't go. It's not working. Oh, no, okay, now it works. So which one?
So you do have numbers for COCO version 01 there, which I think are implementing the aging closer to what we actually had in mind, what V3 means.
No, the aging actually is implemented the same in both cases. So this COCO without aging, it is just then it simply doesn't do the aging. So in that sense, in these experiments, it is equal to the case that if you apply aging only with idle periods.
Okay.
So it never happens. But as we can see with the random clients with infinite buffer, the results are the same. So we still have this every segment, every request is retransmitted at least 4 times, or more or less 4 times. So only 20% useful work that the system does there. And if we increase the load further to the 800 clients, then this is also kind of a more or less double this. So then only 10%, and finally there will be very little forward progress or useful work in the system.
Okay, so the anomaly in the left graph would be fixed by making more clear in the document that aging is only to be used in the idle period. And on the right side, we still have a problem.
if we keep the back-off value for the next request, then the problem should go more or less away.
Okay, so let's.
And with the default code, we are not able to do that, if I understood it.
Yeah.
But after all, it is only one. It's only one variable. So I would say that many systems can afford it. So I think we should recommend a little bit more than what you said, kind of. But you don't necessarily need to implement Cocoa, but you can add one variable. So to keep the timer value.
Then you also have to add a decaying mechanism there.
No, you don't need to have a decay mechanism.
Well,
No,
I think you do.
TCP doesn't have that. You want to stay at the safe side. That's all you need.
Well, again, TCP starts at 3 again. So
Okay, well, let's not go into this discussion. But I know, but we need to be safe with the congestion first, and then to think about the wireless losses. After all, we have, okay, unfortunately, time doesn't allow. We have results for the wireless case as well. So comparing this, there is no dramatic there. There are just differences between the cases. But we intend to publish this shortly. But don't have this here right now for.
thank you.
Carlos Gomez. So I was wondering just a couple of minor details. And by the way, thanks for all this work. It's really helpful. Is it possible that when you mention 01, it is not draft IETF core Cocoa 01, but instead it's draft Borman?
No, it's the working group draft.
And because I think you mentioned that
we implemented it right. It's just we're completing the implementation when the O2 draft came out, so that's why we implemented that one. And then we later implemented the O3, which doesn't have any changes, technical changes in that sense. So it's same as O2.
Yeah. So the difference between 01 and 03.
The variable, the only notable change there is this change how the variable backup factor is kind of treated.
Okay, may need to double check because I think there was not a change in the variable.
There was change.
Okay.
There's a clear change. Maybe not intended, but there was.
Okay, then we need to double check what is intended.
Yeah.
And then just I'm curious why the setting for max retransmit of 20?
Just because otherwise, okay, we can take a quick look at.
Doesn't work.
Mhm.
Which slide number?
To the backup slides.
Which one do you want?
Do backup towards the end.
Towards the end?
This one? Yeah.
Ah,
Okay. So here we have the results with the frequency of transmission saying that how many retransmissions each of the exchanges that we needed. So 0 meaning that no retransmissions, one retransmission, and so on. So here we can see if you use max retransmit of 4, whatever is there on the right hand side, in those cases that client would fail because this this exchange would be aborted, and we won't get the result for that. And in that sense, kind of for that client, the results would not be comparable with the others. So just to make them comparable, we had this. And as we can see, there are some retransmissions beyond 4 retransmissions, which is something less than, in all cases, less than 5% of the cases. So this is also a question that we could raise that if the max retransmit of 4 is the best value, whether it should be a little bit higher, or alternatively, should we kind of actually use the backup factor such that it depends on the maximum retransmits. If the low number of retransmits we allow, then we should use kind of a higher backup factor to ensure that we can get all the kind of get rid of the congestion during the period that we have available. But this is just another discussion, maybe not something to discuss right now here.
Yeah, but Erwin, so if we wouldn't have not changed it max retransmit, we would have this offered load would have varied depending on how many of those clients fail. So because of that, we couldn't have compared those cases so well, because these are sort of random effects. One of the clients might do more of the backups than some other. So the number of clients which are able to complete successfully would have varied if we would have not increased this much retransmit. So this is just to make the test to be useful. Of course, it would be possible to run with this max retransmit for and then some of them fail, but then you have this issue that the offered load would have not been the same between different congestion controls. So it's harder to then compare the flow completion times and whatever.
Well, I think I understand this reason, but anyway, I think it might also be interesting to run the evaluations also for max retransmits at 4.
It wouldn't change the final outcome, because this is just a setup that we are running to a certain number of clients and these 50 exchanges. We could have exactly the same load with larger number of clients that are maybe exchanging every 10 seconds or whatever. It's just depends on what is the amount of offered load, so how many clients you have. You will have exactly the same result. It doesn't matter kind of in that sense.
Yeah, so
We have about 3 minutes left for the topic. So Gori, if you want to give your impression.
Gori first. I'd just like to kind of come back at the end. And first of all, I found that discussion really, really helpful. And when I pointed to Scott Bradner's document and I talked about TCP, I'm talking about TCP flows. You shouldn't directly compare one TCP SYN with one other packet. So you need to talk about it in this way. Talk about the effect of congestion collapse in the network. So congestion collapse is more important, I think, than performance for the network. In doing that, I have some concerns which I think you should look at, which is this idle time. I don't think you can reset RTT without really seriously considering that in the presence of failures. So I think we talked about that, but I think that has to be talked about more. Either it has to be really discussed in the draft, or you have to address the issue. And if you then expand the backoff appropriately, I think you can have a document that actually satisfies the congestion collapse conditions. So please continue to work. Please think on this topic, because I think most of the document's okay, but this particular bit does need more work.
Thank you. Thank you, Marco.
Since you have a bit of time, it's not quite 3 minutes.
1 minute, yes.
Good. This is actually Shelby from ARM. Matthias and I did some work years ago on CoAP at scale. And one thing that concerns me is that do we have the right use case in mind here when we're doing measurements and research around the scenario we're worried about? And what I see happening in the industry right now is co-ops being used in quite a centralized way. Yes, we have some kind of local communication and gateway things over wireless happening, but actually we have very large cloud providers and operators collecting data from hundreds of thousands and now scaling into millions of devices into centralized cloud platforms. So this is big data collection in practice. Have you guys in your simulation work looking at congestion control looked at that kind of scenario? One server communicating with very large numbers of low performance, low bandwidth devices, but there's just lots of them, right?
So basically, yes and no. Now it depends on where your bottleneck is. So how your server communicates or your backend communicates with all these devices. So what is how many parts there are, how many routers there are. All what matters is the bottleneck, where the bottleneck is and what is the offered load over that particular bottleneck. And that's what we are emulating here. We can, for the congestion control point of view, we can kind of make the system more simpler to test how the congestion control actually works, just to have the bottleneck, or in some cases, more than one bottleneck. And then you offer the certain amount of load there, and that's it. Simple as that.
Okay, I think for that we probably need to do a little brainstorming with some of the operators in the room, some of the LP WAN providers, like where these bottlenecks might be showing up, and where we might have fairness problems with TCP traffic. But I can't answer that off the top of my head, where those might be. But just to make sure that what we're doing here is real from an industry perspective.
Thank you. So we essentially consumed most of the Slack time we had gained on Monday. So the next one on the agenda is Yari with DevURN.
Okay, so I'm here to give a short update on this draft, and also have a couple of requests and questions for you guys to try and answer. So, I mean, just to set the stage in case you haven't been in the room before when this has been discussed, the dev URNs are our namespace for hardware device identifiers. We support MAC addresses, EUI64 addresses, one-wire addresses, and also sort of free-form organizational device identifiers, if anybody has those. At the bottom, there's one example, URN dev MAC something something. Pretty simple. And just before the deadline, I posted a 0.0 for the working group version of this draft, and then earlier this week published the 0.1 version. The 0.0 basically was just a copy of the old draft, but some typo was fixed in the ABNF, and then 0.1 actually updated the URN registration template, because they've updated that to, or there's a new RC 8141, I think. It says how to register URNs from now on, or from that point onwards, and we've updated that. And that's a textually fairly large change, and also had to answer more questions than I had answered before, and that's usually a good thing. That the new template actually forces you to think through more cases than the old one. So you'll see some of the findings actually there. So I have a couple of requests and questions. One is that can people read the new template? It just appeared on Monday. So would appreciate feedback. It's new text, so take a look at that. And also, given that there was a few more questions to answer, there were some that I didn't actually know how to answer. And one of them is that the new template asks us to specify how the particular URN type deals with Q, R, or F components in URNs. And I wasn't really sure about this. So for the moment, I just wrote that they're not used. I'm not quite sure if that's the right answer, but would appreciate feedback on that. So that's sort of the basic of this URN type. And there's two classes or two items of another type that we're wondering about, and those relate to possibly adding new branches under the dev URN. So the first one is something that we had discussed briefly in previous IETF, I think, adding device ID specified in one M2M and lightweight M2M groups. And I think we just basically agreed that would be a sensible thing to do. If that's what you still think, then that's great. But since I'm not personally working in those groups, maybe there would be somebody who would be kind enough to send me some text that we should actually add, because we actually have to specify the syntax in detail. And then there was a discussion. Matthias Kovacs and myself discussed a little bit during the hackathon about possibly adding Web of Things device identification schemes that he's developing, and this sort of would seem to possibly fall under the dev URNs, but it could also be separate thing. I remember the dev URNs are not the only way of identifying devices. You can still use UUIDs. You can still use regular URLs even, and so on and so forth. So, or email numbers and so forth. So dev URN is the sort of the catch-all of the things that we missed or have not defined before. We can add more, but we can also do separate. And in this Web of Things scheme, I think it would seem at least that's a thing where you have to define the next step is to define the semantics of that, how they get allocated underneath this high level branch of the tree, and then go from there. I would recommend that's probably a separate draft. So that's it really. So feedback on the template, answer to my question on the different components that could or could not be used in the URN, and then what to do about these additional things. I think my general approach is that if I don't get text or clarity on some additional thing, then my inclination would be to try and publish the RFC, because you can always, it's possible to add more branches under dev URN later also. So that's it. Looking for feedback.
Sorry, can you remind me, is UUID already one of the types?
I'm sorry, I didn't quite hear you.
Dave
UUID.
Taylor. So my name is Dave Taylor. The question is, can you remind me, is UUID already one of the types?
No, that's a separate URN type.
Okay, so you're
It's
saying
not
you
under
just,
dev
use
URN.
you just use the UUID colon or whatever instead of the URN colon for
Right.
that one, and that's why it's not in there.
Yeah.
Okay.
So my point was that there's other URN types that you can also use to identify.
That are not under the
things.
URN colon scheme. Yeah. So there's URN in the general sense, there's URN in the scheme name sense. Yeah.
Hi, I'm Padu from Nokia. So this third bullet about decision and text, not unclear like what is expected from lightweight M2M. But what we have done is, I believe with 1.1 release right now, what we are working in OMA, we have the URNs and URLs are basically, I understand it's all under URI. So lightweight M2M could do a URI, meaning anything under the subset can be a device ID. That's what we have updated. It's still a draft. So it's unclear like how to handle that.
Okay, so I'm not very well aware of the details of what you guys are doing. So that might be maybe an offline thing for us to look into this. I would fully understand what's going on there, and maybe it's the case that we don't need to do anything. I'm just basically standing here saying that if anybody has a burning need to add things to these URN types, then now would be a good time to say yes, please add, and then give me text. Otherwise, we're moving ahead. Yeah, I don't see a lot of screaming or requests or more answers, so.
Thank you very much for the update. So in the meanwhile, the next one, I believe, is this one is done. Just a second. There. Make a request tag. Maybe that doesn't work.
Hello everyone. So for whoever hasn't seen the presentation on resource directory yesterday, my name is Christian Amsus, and I will be presenting the latest state of the echo and request tag. Okay. the echo and request tag document that Göran, John, and I are working on. So just for brief context, what this does is provide solutions to some security issues that were found with basic co-op mechanisms and the DTLS bindings that also show up in other security wrappers. So, for example, what happens if packages get delayed for a really long time by an adversary? And this document provides some solutions to that. There is, in parallel to it, a document that outlines all the attacks that is being updated constantly. But this should be concise and provide everything that's needed, for example, for OSCORE to solve those issues and to also solve those issues with other security bindings. So what happened since the last meeting is that token processing was added. This would now update RFC 7252 because as tokens were described to work over DTLS, those could result in responses being matched to requests that they don't belong to. So this is one of the updates. The second update is that the whole echo section was a bit shuffled around to be readable more easily. And
Oops. USB-C connectors at work.
So wasn't that me?
I touched my laptop. Never do that.
And the third part is that the request tag option, which originally had quite a bit of details on how this interacts with blockwise and assembly of options, can be much easier, provided that the understanding that we've come to develop of how blockwise is intended to work is correct. Now, we've discussed this with various people in the working group already during the last few days, and it probably that understanding is probably correct, and that means that the option is just what has been suggested in RFC 7959 as if you want to do kind of sort of simultaneous blockwise operations, just add an option that is safe to forward and part of the cache key. Now request tag will be exactly that option, and it won't need any normative text on how it is used server side, because this is just how it can work with blockwise anyway. And the text we're having there is how do you apply this if you're a client and it matters to you that your blocks aren't shuffled around. This in the current draft version, this is only being hinted at because it, as I said, it is under active development. There will be an updated version roughly at the end of the week or shortly after that, which will be a bit shorter. And if you have any opinion of whether this can work that way, by saying that blockwise operates on cache key data, and if it's part of the cache key, the blocks are safe. If you have any opinion on that, please voice it now, because the results of this will probably go also into lightweight implementation guidance and basically clarify what was intended with RFC 7959. If someone has divergent opinions of that, please utter them, because otherwise we'll proceed on with working on that.
So the normative part will be this option has no semantics?
The normative part will largely be to the server. This option has no semantics, yes?
Yeah, and of course we still want to keep the informative part while we're defining this thing. And also it's probably a good idea to have a common understanding in the co-op community which option you use for sending something that doesn't have any semantics, because you want to keep block requests together.
Yes.
So I think it's just moving over some material. It's not really actually a big change, but
yeah.
Good.
So as soon as that new version is out, I'd ask you to review it so it can proceed easily, because it's basically just fixing stuff that is already well understood.
Can we see a few hands of people who would like to review this? Jim, Carsten, Jaime. I can't see you. Julian, Francesca, Michael. Okay, that should be enough.
Thank you.
I think the timeline of this should be, we shouldn't be sitting for too long on it because it solves some real problems. Yeah, next version, reviews, working blast call, ship it. Thank you. So we are back to our favorite item. We started that discussion yesterday afternoon, and we still have to finish the discussion. And I offered my discussion contribution here on this slide, and everybody has had a chance to think about the pending issue during the last 20 hours or so. So I would love to hear other views on this subject. How should we handle this in general, and how do we handle specifically the pending requirement that comes from the EST document? So anybody have an opinion on this? One person is getting up. One person is leaving the room. No.
Was a long way. Matthias Kovac, Siemens. So what I see from the two proposals are two different strategies. One is to handle it explicitly as part of the states of the state machine. And the other one is basically the mechanics of the state machine that we want to define. So the proposal having new response codes and so on, this is more on the meta level. So there, it's basically some basic implementation that has to deal with that. You do not have to think about it in your application. The maybe proposal is more, okay, you have to design your applications following the state machine thoughts, kind of the hypermedia way how to do this, and yeah, have it explicit in your application. So a question is, are all applications recommended to follow this approach? Of course, it's something we would like to see, but maybe it goes a bit too far if we kind of make them all do this and use the media types as they should be. We have a lot of proposals that use co-op in a more simple way, that use what is defined there, and they don't put so much thought into how to design a hypermedia-driven application, meaning these thinking about what are the states of the state machine and so on, what is the right media type to use, and so on. I think in particular for this PubSub draft, a nicer solution for that would be to have it on the meta level, so meaning the new response code, because PubSub, people who we want to adapt that won't think in this hypermedia terms. So these are my thoughts on this. So it's I see it's two different strategies how to solve this. One is on the meta level, having it how state machines can be defined using co-op, and the other one is, okay, you have to model this with the means co-op gives you directly in the state machine of your application. That would be the maybe version or proposal.
Yes, but no, what position do you take on this? Maybe I'm not quite following.
So I don't have a strong one, as I said, so it depends on the application. So on the one hand side, it would be nice if more applications would follow the hypermedia-driven approach. Would be good to have something there, but then if I look at the case of PubSub, where we want to have people at least move, let's say, from MQTT to co-op PubSub, where we have some more metadata on what is the content center around, we have more features for interoperability, then let's make it easy for them. And then I think this response code solution is a nicer one. There are cases for both, that's kind of the main message. So I see both solutions, they are valid, but it's two different domains where they are valid. And so I haven't thought a lot about the EST use case. But I think that's a similar case. It's not people designing hypermedia-driven applications, but it's they're using the CoAP protocol and they look, okay, what are the mechanics of this protocol and how does it map to my problem? And so it's, I think, the same bin as this PubSub, where they just want to have some mechanics on the meta level of the protocol and define what needs to be done.
Peter van der Stok, because it's my turn, I think, to say. Actually, I agree completely with Matthias about if you have a response code, it is of more general nature than when you use the media format. The media format actually is for a client which talks to a server, and they are part of one application. So they know about what things are going, and there's no need to export all this knowledge about what the media format means. Well, in the other case, when you want to have a more general service, you have the response code. I think it can be used also by other applications. You should like to try a response code. I understand that there are problems, because there may be proxies which do not understand it and do not pass through the values as you wish. And on the other side, it might be that you have a client who gets a response back who doesn't understand it. I think that it depends very much on the type of a response code that you do and the kind of consequences which are passed to this return, which should actually help the working group decide if one likes to keep this response code and introduce it or not. Yep.
Are you going to answer to this, or can I? No, okay. Alexander Pelov. So I'd like to see like one use case or an application that will say, how does this map and why do we do this? So it seems to me like it's a pretty meta approach, and like, yes, we could do it, and yes, but what it will serve for, like one specific use case, and when we see, okay, well, we solve this problem, and then we can say, yes, it's interesting, or maybe not.
Michael Koster, Smart Things. Excuse my voice. I agree with the idea that this is more application oriented, and the idea of a response code, status code is more transfer layer. So, PubSub, I agree that PubSub just transfers representations. So we really probably can't try to synthesize media types in PubSub. In terms of the other use case, I don't have much to say, but I think I'd like to see a little more discussion on what's wrong with response codes.
Okay, Carsten Mohr from the floor. I'm a computer scientist, and I think good computer scientists are fundamentally lazy. Applying this principle here, should we have this kind of discussion each time somebody comes up with an application? If we can come up with a couple of response codes that we really think add something to the ecosystem in a general sense, I would be really happy to embrace them. But the two response codes or the two applications that have been discussed here so far, those are just specific things, and I do believe we should guide application developers to defining media types for their application states. So on one hand, I agree with Matthias, maybe to the level of saying, yes, there is a decision to be made, but I would prefer to only have response codes for things that actually are somewhat universal. Now, to the question, what's bad about a response code? That's in general, nothing is bad about a response code. So, for instance, we can add 4xx and 5xx response codes as soon as we understand what we're trying to do, and we will do that for too many messages. A success response code has a bit more baggage to it, because we are assuming that the CoAP layer knows how to handle this response code. So things like proxies, but also the CoAP layers, the caching layer in a client implementation has to know about the response code. And what I really don't want to get is a situation in which somebody cannot get their application going because their CoAP layer, their CoAP library, or the proxy that they're using hasn't defined that response code yet. So that's really a bad situation where to make a deployment, you actually have multiple entities to agree that it's a good idea to do that deployment. We generally try to avoid that. So that's why I generally think we should guide application developers towards solving this with the means that CoAP has already available, and one of these means is media types. Now, on the general question of having a resource, and that resource isn't currently quite in a state to provide useful information. I think one property of this situation is that the application probably wants to say something about the characteristics of this state of not yet having useful information. So in some cases, it may want to say, come here again in 30 minutes. In some cases, it may want to say, nobody has submitted anything to this topic yet, but here's a default value, and so on. So this is fundamentally application specific and calls for an application specific media type already. So I don't think it's a lot of onus on an application developer to develop that media type. And the final observation, one problem we ran into when looking at the PubSub case is that observe currently requires all the notifications in a stream of responses to have the same content format. That may have been a mistake. So yeah, maybe we want to fix that mistake, but maybe people don't agree it's a mistake. So I'm interested to hear more input.
Azek, you didn't have, or that was already? Okay. Yeah, so I came a bit late to this discussion. So I discussed a bit during the hackathon. What is the issue there? So for the PubSub use case, it is exactly what Carsten just mentioned. To me, yeah, at first glance, it feels like, okay, this is kind of a strong correction or change in the observe RFC. Maybe then having something more drastic, let's say, like a response code that can fix that might be the right direction, because there were some thoughts why it should be the same media content format during an observation. I think that's something you should think about. So the main point is it's connected to a lot of other decisions that have been made. And now that more and more applications pop up, we actually get more evidence what would have been maybe the right decision. With the response codes, it's a bit similar to the methods. So we originally stuck to a minimal set. Then it turned out, yeah, actually these additional methods are a good idea. They help optimizing. They solve particular use cases, especially if you look at fetch. And for the response code, so for instance, there's also still this gap. What if you just want to say, yes, this was processed correctly, the resource state didn't change, so it's not a change. There's no content to return. There's also still a gap, and it's like the workarounds that we had, let's say in HTTP, when there was no patch method to send a post, and everything was a bit, yeah, sloppy, let's say, because there was a gap in the specification. So I think with the evidence that we have, maybe we can collect more of these use cases where everyone has a problem to pick the right solution from the RFCs and rethink what are the response codes that we need. So again, it's connected to many issues actually. So it's not really, okay, what do we need to solve this EST or this particular PubSub problem, but more in the overall design space.
So the way that you described, Matthias, the new response code actually would have semantics that are quite similar to 205, except that the what you get back is not the content, but some meta information about that content. Is that what you were saying?
So this isn't fully figured out. So I started thinking about this during the hackathon. So the one thing about this response code in question here, it tells you, okay, there's this resource, everything is fine, but there is no content. So it's kind of this HTTP 204 no content. And something similar was missing in these cases where you send a post to process something and you don't change resource state. There's also kind of no content to deliver it, but that is more like a 200 okay, a generic, okay, I processed this correctly, and maybe the 200 is too generic for saying that. Maybe it's the same thing that we need. It's some something no content that would solve these two issues.
The 204, the HTTP 204 actually has, even though it's described as no content, has a slightly different semantics. Which is the previous content you already got for this is still valid and you don't have to update it. It's really weird that this thing is called no content. So I'm not sure we can draw a parallel to HTTP here, but maybe that's one question that we should try to decide for this new response code. What does it mean about the actual content behind that resource that may already be cached? So is that replaced, or is it still valid, like in the HTTP 204 case?
Just an observation here. So the 204, I think, was also returned if you change something, because HTTP doesn't have the explicit changed response code and so on. So this is originally already this problem. Okay, I don't really have the right thing to pick from. There's the general confusion from the name of the response code to the actual semantics. And we, I think, are stuck in the same problem here, but with the expectation that co-op is for machine to machine. So we have to be way more explicit about all this.
Yeah, so I would propose that we define a new response code, not what you wanted. And that is used for representations that come back that are not what was originally requested, but that somehow are useful in the application to make progress. And successful, yes. Successful, not what you wanted. Not cacheable. I think that's a significant observation here. And may have a different content format, keeps the observation alive.
I agree, the 12-4 semantic is that you're supposed to remember the last values.
Can you use the microphone?
Still there. Michael Koster, Smart Things. Yeah. On further reading, the 204 does, in HTTP, does instruct the client to use the previous value, so that would not be appropriate for the PubSub case, the same semantic. We do need something a little different. I believe the other one was more analogous to 202 accepted, which says something like, I might process this later or I might not. And 202 accepted is used in some IoT APIs for go deal with this some other way. Like, for example, one API uses it to indicate that you're supposed to go get your asynchronous notifications somewhere else. So you do an HTTP thing that says, hey, like I want to observe, but it says, it gives you back a 202, and it says, here's where you go observe this thing. And that's or it's not a redirect, but it's a, I'm processing this, but you have to get your answer somewhere else. I'm not sure if that's exactly what Peter's use case is either, but I think what you said is, I kind of agree with that. That's really what the semantics of what we want to say for PubSub is not what you wanted in a general case. So doing that would cover PubSub and as well as maybe some other general cases.
Arker and Ericsson, I think we need a response code, but maybe the one you suggest is something generic. Okay, yeah, here's more information how to go forward. Maybe that is actually the right solution here. So instead of having three new success codes, just having one that is relatively future-proof. I think that would be solving the PubSub case and most likely the EST case too. So I would think makes sense to explore that.
So I think what Michael just said is interesting. There are cases out there that we could look at, and particular IoT cases out there. And maybe we should spend a couple of days of collecting these cases. So if you have a pointer to the API, so other people can look at that as well, that would be a useful thing to take to the list. So for once, I think take to the list is exactly the right thing. But we have a couple of days at this IETF, so we can continue discussing this, but it seems to me we are kind of converging on something here. Great. So let's jump into PubSub itself. Where's the pointer? There. Yeah. Yep.
Okay, I'm going to just go through all three of these since they're all in order. I just made one set of slides for the whole thing. On PubSub, we did not get as much work as we hoped done, but we made some incremental progress.
You can look at the screen in front of you.
Oh, thanks. So what we want to do is split out these response codes into separate drafts so that there's no dependency or impact. And we're going to need to we're creating a dependency, but we don't want them internal in the draft. We want them to be, as Carson said, general purpose for everyone to use. So we'd like to just refer to those, whatever the no content one, that's the TBD. Too many requests seems to be less controversial, so that shouldn't be a problem. Now that we have a really clear idea of how PubSub and groups and multicast and different sort of security considerations are, at least a better idea than we had a year ago, we're ready to put some specific stuff into the security considerations for OS Core. And there are some more issues and comments that we need to address. Some really good issues, really, some sort of unspecified cases, like we have a PubSub resource that's a resource type that works sort of like the RD resource type does, that's where you sort of access the functions and queries and stuff. And the question is, do all the topics sort of show up under that in the tree, or are they able to be sort of created just anywhere? Conditional notification, it seems like conditional notification and PubSub are two patterns that really need to be used together. Even though we don't really have the numeric stuff, we have pmin and pmax that would be really good for controlling the flow of data, a proactive way instead of depending on 429 when things go wrong. So we'd like to look at that. And also DynLink, just to be able to use dynamic links with PubSub. How do you use that with a broker? Do we create a binding table on the broker, or do we have a way of putting link bindings with associating with topics in the tree? So that needs to be worked. And also there are some questions around how topic discoveries work with topic trees when you create things with a number of levels all at once. Are there intermediate nodes created? And we need to be clear about that. And there may be a couple of other small issues, but I think this is the flavor of what's left to nail down before we're done. So that bit of work left to be done. We'd like to schedule an interim meeting so that we can be ready for last call by the next IETF. It's basically how we'd like to proceed. So sort of do one big final push, sort of the way we did with RD, to just get everything in and get it done before as a deadline for IETF 102.
Yeah, that raises an interesting question. We have been using virtual interims in the core working group a lot previously. but not recently. And we may want to get back into the habit of having some. Now, what would be the right time for an interim meeting that finishes PubSub?
That's a good question. It kind of feels like it's like next month sometime, or April or May, right?
Are you sure that you can do this in 1 month?
Well, maybe. So when is the IETF is July.
Yeah, so
it could be June.
The mid point would be sometime in May.
Right, that's, yeah.
And we also could go for 2 interim meetings, and then one would be early May and the other one would be late June or something like that.
At this point, it doesn't feel like we have that much work to do, but I could be surprised. We could be surprised.
Okay. So we don't have to do the scheduling now, but maybe we can take down that we want to have something in April or May as an interim meeting, at least for this, and maybe for a few other things like the new response code.
I think maybe even as
well.
some of the others too, that we want to continue to make, and earlier is probably better because we really kind of have an idea of the scope now, but if we get some more working group review and some more comments, the scope may get larger. So please, if anyone really cares, now's the time to do the review.
So who has read a version of the PubSub document? Almost 20 hands. And who is willing to contribute a review of the document? Jim, I see a hand, but I can't see the person behind that. Thank you. Krista, and 2? Well, 2 is better than nothing.
Okay, thank you. Okay, no discussion. Yes. Oh.
Yes.
Oh, you split the slides.
Yes, because we have two items.
Okay, so
go ahead.
Okay, great.
Michael, before we go forward, if we have time, I think it would be good to discuss the point, like, by the way, this is Ari Keränen, discuss the point, where do we want our topic tree to land? Do we always want it to have under the API resource, or would we like to have the topics anywhere? So that's the first bullet over here.
Yep.
I can see arguments either way. We couldn't really conclude like what is the right way to go here, or does anyone even care?
Is this something we need to prescribe, given that it's all linked together in the PubSub broker anyway?
No, there's a link to everything, and you know, it doesn't really break anything. So the leaning toward, yeah, you can put starts with /URI if you want, or you can put relative URI when you create a topic, and it'll do the right thing because those are all well-known patterns.
So then the broker would just deny requests that are not compatible with whatever policy it's using. I think that's one way we can describe it, if we don't want to have any normative text on the draft on that. But anyway, I guess that's okay.
But we'll need to add description of what happens. So it's unambiguous right now. Okay. Other questions, comments? So I'm going to talk about interfaces in DynLink now, which are also pretty close in our opinion. So the interfaces draft is really just informational. We define some link attributes, IF, and interfaces draft basically is some high-level guidance about what this IF attribute is about. And you can use it to say this thing is a sensor, this thing's an actuator, this thing is a collection that has stuff in it. It's basically an application layer tag that tells you how to process the resource. So originally, other SDOs, notably OCF, are using interface, and their examples are a lot different from ours. There was an idea that we would try to show what OCF is doing in our draft, but I think we've decided not to do that and to keep with our original examples. At least that's what we propose. You can go look at the OCF spec if you want to see how OCF uses interfaces. And I don't really see a lot of value in duplicating all that in our IETF spec. It won't be normative. Maybe we, if people feel strongly about it, we could bring in a couple of examples, but we should show different ways of doing it, if anything, and not try to imply that there's only one way to use the interface's target attribute. What's happening? Is someone coming to the mic on Meet Echo? No. Why did the display change? Oh, okay, it doesn't matter. All right, so that might be a little controversial, but that's done in a reason to simplify things, and also we're going to use SenML. So it's sort of like the examples are going to be more SenML examples that show content that's according to another IETF draft, which seems to be a little more consistent than bringing in stuff from an external SDO. And we have some remaining issues to close, but not too much. So we want to do the same thing here and address all those comments and issues before the next, and prepare for working group last call. We may or may not be prepared by then, but we want to prepare for that at IETF 102.
Do you want to prepare at IETF 102, or do you want to have the last call?
We want to have the last call at IETF 102, yes. But we want to be prepared to do that. I guess.
Okay.
Yes.
Thank you.
I guess it's just a little less certain that we'll have everything done versus PubSub, where we really sort of feel like we need to tie it up. But that's because I guess we were just not quite sure about the state of that draft relative to the other ones. Am I representing this correctly, Bill? Because Bill Silverajan has been doing a lot of the work on this draft lately, and but we're all pulling together here. Okay, so DynLink is a little more going on with it, but probably a little less work to do. We really kind of understand the scope of how we want to finish DynLink. There are two components in the DynLink draft. There's dynamic links that define, it sort of uses a link to define an asynchronous data transfer from one resource to another. So it's when this thing generates something that needs to be updated, then it causes the transfer to happen. The other thing in the draft is conditional notification parameters, which basically we call them observe attributes in some other areas, and basically they control the notification behavior. So it's sort of the timing and how much the value needs to change and things like that. The conditional notification parameters could be included in the dynamic link, so that's really one way to use them. You put them in the dynamic link, and that defines the parameters of the notification links, how frequently and how much change. They can also be applied to a resource instance and be stored in a resource instance along with the resource to have sort of a global notification behavior for that resource. And they can also be, the third way that we've looked at is applied to an observation instance to, I guess I lost the rest of the sentence, but basically each observed can have its own set of parameters as well that you plug in with query parameters on the get. So we want to make sure we define all those three ways of using parameters really clearly. I think it's probably already there, but mainly we want to put the draft into two sections, have the dynamic links in one section and the observed parameters in the other. And then there's a thing about a binding table, which is how you might organize things on a server, but they don't all have to be organized that way. That's optional. So we kind of know what we want to do with it. We have one thing that we're adding, and that is another notification attribute. We looked at a lot of different notification attributes to have a lot of different, tunable behavior and what have you. And the one that seemed to really stand out as being consistently, people say, why didn't you do it this way, is to have the notification happen within a certain signal range, value range, and not when you're outside of that value range. And this was a really popular, this was in working with lightweight M2M, originally a lot of the folks thought that that's what LT and GT were for, was to say you only notify when you're between LT and GT or outside limits or whatever. They wanted to have the endpoint be quiet when nothing was happening and only do notifications when something unusual was happening. So we're adding the band attribute to modify the behavior of LT and GT to be this notify within band. So if you use LT and GT in that band as a Boolean flag, then you get the special behavior on those. If you don't, you just get notifications when LT and GT are crossed as a limit, sort of a crossing limit behavior. And then finally, we decided not to rename LT, even though resource directory uses LT as lifetime. We don't see any significant conflict there. So we'd like to keep this as LT.
And Dave, can you clarify when you're actually using it as a bandpass? Can you say only notify when you're outside the range?
Yeah, so just make LT greater than GT.
Okay, so you allow both within this and on both
Exactly.
ends. Okay,
Band
that's-
exclusive
I
as
wasn't
well.
clear if you allowed both. So
Band
great.
exclusive is maybe the usual case.
Yeah, because your example there with the and there implies that it's only when it's in between the two, right? Instead of on the two extremes, right? And so this is the second
Right,
example.
greater than GT and less than
Right,
LT.
so in other words, if I
That's
want it to be
correct.
silent in the normal range and be signaled only when it's outside normal range, then it's actually the opposite of that example, right? And so you're saying you allow both.
That's right. GT is normally the lower one if you want in band, and GT is the upper one if you want out of band.
Right, so whether it's an and or an or, it depends on whether GT or LT values are higher versus lower, right? You're saying that's how you switch.
Exactly. That's it. And we'll clarify that in the draft. And we probably need some examples there to show some ASCII art that I signed up to create a little ASCII art to illustrate those. And the roadmap, the last changes are scoped. We want to, do these three things. Security considerations. We didn't really talk a lot about that, but when you have a dynamic link, there's sort of an implication that there's some client functionality there that has to process the link to output, to generate a transaction, and that has a lot of security implications. Like, who's doing it? What's the subject? If you have ACLs, where does, so I think it's out of scope for the draft, but it's definitely needs to be brought up as a security consideration and needs to be resolved in any real system that uses these. Right, and we want to also have working group last call at the next IETF. So I say prepare, but it means prepare to have everything ready so that we can ask for last call if that seems to make sense.
Good. So I forgot to ask the question for interfaces, but I'm going to ask it for DynLink first. Who has read a recent version of the DynLink document? Christian, and one hand behind Carlos. So who's that? Thank you.
Mojan.
And who would be willing to contribute a review? Christian and Christian. Okay, and Mojan and Ari, thank you. And on the subject of the interfaces document, who has read a recent version? Christian and Zach. So we probably should reserve the first row for Christian because he has read all the drafts. And who would be willing to contribute a review of interfaces? Christian. It's always a bit harder to get people to review informational documents, so we know that, but it's probably still worth finishing this work. Okay, I think we're done. Next. Bill.
Okay, yeah. All right, so we'll start with protocol negotiation first. So there are two drafts right now that that are separated for alternative transports. One is for describing where the transport information should be residing in the URI, and the other one is for discovering alternate transport endpoints. So protocol negotiation is about doing the second part. Bit of context. So the document aims at talking about CoAP nodes that have multiple transports, and then they wish to allow CoAP request and response to use some or all of these transports. So we started with thinking only about per server models, but then recent discussions also showed that per resource models are useful. And then also the draft evolved. So initially we went with a core resource directory only model, and then right now we also have a model where you can directly query the origin servers for the available transports. Okay. Current status. So we are in draft 08. We did not introduce anything new. We clarified some of the parameters based on reviews that we received. And also thanks to Christian for doing good work on the resource directory. So from that, we were able to do quite a lot more. We have the OL, other locations attribute that allows multiple base URIs and to align it with the way OCF does it. And then we have the AT and TT parameters, which are also repeatable, that you do the same thing with the resource directory. So there was a request to provide more complex examples, and that was incorporated with the current draft. And then there's some example usage that's updated with the way resource directory is structured right now. That's basically it. So next steps we have are, one thing that I omitted in this slide is basically that we have a huge section that we need to consider for security. So security considerations plays a really important part in this area. So something that I neglected to put in the slides. But anyway, we're still looking to see if there are other mechanisms that we can use in terms of allowing the client server discovery for alternate transports. And one way is looking and seeing some of the suggestions actually came from the corridor discussions that we had, and some came from the reviews. And these were some methods that we think we will, going forward, we'll try to evaluate them and see if there are any of them have any viable ways of doing that. So, for example, using fetch to provide a payload when you do a request, and then retrieving the list of transport endpoints, or then using a well-known location for site-wide metadata, or then doing what we do in DYNE links with binding table entry. So in that sense, that basically we can just use a resource collection, and then try to add or delete web links that tell where the locations of the endpoints are. That's it, I think. So, any questions about that?
Okay, so who has read the recent version of this document? Christian has, no surprise. Yeah, I think a few other people have, but I'm afraid to put up their hand because I might ask them to put in a review. So I think these two documents, there are currently two separate documents, but maybe we want to revisit that at some point. So maybe we can go into the other document quickly and then discuss this some more.
Yeah, the other document is even easier, since this work is currently, in my opinion, it's complete. So
we'll just actually, from the point of view of lightweight M2M, since we have now multiple transports, I believe the protocol negotiation one could be also useful. We are finishing 1.1, maybe on 1.2. It could be something discussed. I don't know what Padu or Zach or Hannes, if he's in the room, would think, but it sounds like a useful feature.
Yeah, I would be happy to get some text to look at examples of how OCF or OMA do that work in lightweight M2M. Certainly, be good. Okay. Okay, so right. Okay, so coming back to the second slide set, alternate transports was originally we looked at the work to see. This was at the point when we had not yet done RFC 8323, and there were drafts emerging looking at how CoAP was being used other transports than UDP. So we wanted to figure out how if you wish to expose the transport endpoint in a URI, how do you do it? So the work took a while, and we discovered that when you look at all the URI components, you can't put it in the query, the path, and the authority, and certainly not the fragment. And with the requirements that we had, the only place that left to do that was in the URI scheme. So the draft basically just crystallizes that point, tells you the design decisions that drove the decision that currently is being used by RFC 8323 to list the core TCP and WebSockets information in the URI scheme. So the current draft 11 is just a small delta, and yeah, that's basically it.
So it seems to me this draft is in a weird state because it documents analysis that led to RFC 8323 being what it is. How are we going to use this analysis next? So one thing that we left unfinished when we completed 8323 was how do you actually do a URL scheme that is open with respect to the transport being done. And we kind of have an unpaid IOU with Adam Roach on this one because we agreed with him that we should have such a URL scheme as well, but we haven't really done the work on that yet. And I think the protocol negotiation draft certainly will go into that in some form. This will go into that in some form. But also we probably want to specifically define what such an URL scheme, which has been referred to as CoAP plus AT by some people, how such a URL scheme would work in practice. Now Dave is going to remind us that OCF already has such a URL scheme, which is specific to the way OCF is naming endpoints. Maybe that is also something that we also have to take into consideration when doing something like a more general CoAP plus AT scheme. So I think we have two nice pieces of raw material here, and we have an unfinished, unpaid check. And where will we take it from here? Dave.
Dave Taylor, what Carson said I was going to say. And then to extend on that, I'd say my comment is not entirely specific to OCF, although you're correct that is sort of the main case that we know of today that's making use of CoAP and so on. But I would say anytime that you have an organization or a vendor or whatever that makes use of CoAP, but potentially makes use of transports besides CoAP, then such an organization would probably never use a CoAP-AT. They'd need something that wasn't CoAP specific. Like OCF : isn't CoAP specific. You can have EPs that are, CoAP plus TCP, HTTP, something else that isn't invented yet or whatever, right? Because it's an agnostic higher layer that you can resolve to any transport. And so when you're talking about transports, whether you're talking about transports under CoAP or whether you're talking about transports that include CoAP, and there's other things, HTTP or what have you that's in parallel to that some higher level protocol might run over. All that's part of the larger protocol negotiation or endpoint discovery problem. OCF discovers that by having a higher layer that is not a CoAP specific layer, right? It's just a generic resource layer, right? And so that's something we should take into account when trying to figure out what the scope of these things is and to what extent we're going to go to CoAP plus AT. Is anybody going to use it? And if so, how, right? That's what we should know. Because right now OCF would never use that, right? And we should do it so that somebody would actually use it. And if our customers in OCF, we should figure out what the requirements are and tailor it to somebody that would actually use it.
So let me throw out a straw man. We rename this UI scheme into REST : // Now you know what the implications of that are.
When you say this scheme, you mean the COAP plus AT scheme?
Yes.
Yeah, that's exactly the sort of thing that I'm arguing for, is to say, if you do that, and then you can use, whether it's, OL or whatever, which can point to things which may or may not start with COAP plus, okay? Because if you don't constrain it to that so that it could be extended in the future if something else comes along, then yes, that's exactly what I'm arguing for, yeah.
Okay.
And then you're basically covering the OCF use case, and it depends on, what the rest of the syntax says, which you mentioned, what's the right way that you're naming things and so on, and whether you're naming things along the lines of what Yari presented or something else, right? Right, Michael, not at the mic, Michael Koster, that's a generalization of the pattern, so.
I actually just want to sit down.
Is this on our list for Friday?
It should be. Let's check. But yeah. So David's reminding us that we have a joint meeting on Friday between OCF, W3C, Web of Things, and T2TRG. So that would definitely be something that we want to coordinate if we want to go forward with that. So who can write the draft so we can look at it on Friday? Yeah, so I think the most critical issue is one that has irked us for a long time, which is endpoint naming. And I think we finally have to bite the bullet on this one and agree what we want to do there. So Bill, can we count on you in helping us with that?
Not by Friday.
Not by Friday.
Perhaps I can take a first stab at this and see how it goes.
Okay, so I take it that we just have transmogrified this set of two documents into a slightly larger work item, which is again an unpaid check that we still have with Adam Roach, and also something that I think the community really could use. So let's take this discussion offline and make some progress there. Okay. Thank you. Okay, so we finally have arrived at the flexible time part of the meeting. And right now, the only slide set I have is about OPC UA. Laurent, do you want to say anything about the timescale thing? Nothing new to report. Okay. So where are we with timescale? Do we want to have working group adoption? What are the next steps there?
Yes, Laurent, yes, I would like to have a working group adoption, but it's a working group that have to put comment on this draft. So the goal was to have some, when you send a co-op request, then to say how long you can keep it in the server. So when you have very slow devices, it could be very important. But we need feedback from the group on this.
Okay. So who else is interested in this option? Okay, all the LP-WAN people are raising their hand. So yeah, we know who you are. Good. Yeah, so maybe we should take this offline and maybe use a break at some point and discuss how to make progress with this.
Okay.
So that was the timescale segment, and now let's go to the OPC UA segment. There are 7 names on this slide. I don't know who's actually going to present this. So we had a presentation on this last time, and there was some pretty good feedback from the working group. So I'm looking forward to this.
Okay, thank you. Okay, this is Junrui Wu, and our draft name is OPC UA message transmission method over crop. We have presented it at last meeting, and we updated this new version. Oh, sorry. We made some meaningful changes according to the last meeting commands, especially adding some use cases. So we added some in this version. For resource-constrained industrial scenarios, if we want to use OPCOA to consolidate different types of data and protocols into a unified information model, as well as using web service, HTTP is not a good choice because it's too heavy. Using CROP instead of HTTP is a better choice because it can achieve lightweight communication. The first use cases was based on this, and we only needed to change OPCOA client and server to support this way. The second use case is using CROP to HTTP proxy. It's not necessary to change OPCOA client. With developing of the cloud technology, the factory's data can be uploaded to the cloud for further processing, and many clouds APIs could support OPCOA and CROP. So OPCOA over CROP can let field devices to let the field devices to use cloud APIs directly and quickly. The other change, we consolidate two transmission schemes, the proxy for OPCOA CROP and the direct transmission into one to realize better transmission performance. Due to the expired membership of OPC Foundation, we have not contacted with OPC Foundation working group yet, and in the few weeks, we will contact with them for further feedback. And we will implement the transmission scheme mentioned above over a reasonable architecture. We think the combination of OPCOA and the CROP is meaningful, so we wish to get more feedback. Thank you. Any comment or question?
Dave Taylor. So yeah, I agree. Your next step should be to go to the OPC Foundation, get reviewed there as we talked about last IETF, because I think it's just informational to us that this work really belongs, if they accept it, in the OPC Foundation, not here, right? Because it's on top of us, it's a user of us. And so they would be the ones that do the bindings from OPCOA to various things. Within that, my comments are sort of technical comments or questions that might be more appropriate in that forum than this one, but I'm happy to give them to you now since I'm here and I'm not there. Which my understanding is that the only although the OPCOA defines like 3 or 4 different transports, which you have the good picture in the draft. The only one that's actually used is not HTTP. It's the one that's TCP. And here you mentioned CoAP, and I don't remember if in the draft you talk about CoAP versus over UDP versus CoAP TCP. But for the cloud, it seems like you'd care about the CoAP TCP thing. And so I guess that's part of a question here is, do you assume it's CoAP TCP because you care about congestion control across the internet to the cloud? And the second question would be, have you compared the compression that you get from CoAP and CBOR against the UA binaries compression when using OPC UA TCP? And is it comparable? Is it significantly better or whatever? So that would be my questions.
Okay, thank you, Dave.
Good. So I think we continue to be interested in finding out what other organizations might be using our protocol and what influence this has on further design decisions. So I would then encourage you to bring back your work to us again. But as Dave said, it really would be good to know what OPC Foundation thinks about this. And it also would be good to have some numbers like the message sizes, the compression that Dave talked about. Okay, thank you very much. So we are 15 minutes ahead of schedule and we're done with our agenda, so we can have a brief open mic session and then go to early lunch. So is there anything that anybody wants to say at this point in time? Yes. Dave asked who is going to be at the OCF W3C T2TRG meeting on Friday. So that's 1, 2, 3, 4, 5, 6.
Will it be, what about remote participation? Do you have that ability? I mean, on the mailing list on core, maybe you guys could send some information on how to join.
Yeah, that has been sent to the research group mailing list, and Bill just said he might be.
Yeah, Argen, I also sent on the core mailing list the remote participation details. So they are all in the GitHub and core list and in the RG list.
Thank you. Thank you. Okay, anything else? Then thank you and see you in Montreal, or at the interim before that. You're all right.
Yeah, but the transport side was a bit too long.
No, it was great. Yes, I'm waiting for them too. So they are almost done, but I was interrupted by the start of this meeting.
Yeah, I guess. Could you send me a message, like a Telegram message when you
Yes, we do.
send me, so I
Yes.
can upload them as soon as
Come vai?
Huh?
Come vai? Tudo bem?
Okay.
Vocês estão aqui?
Stressed, for sure.
E succede?
No, nothing. We just have to hopefully be useful, solving issues.